And now, ladies and gentlemen, we would like to commence session 1, FoodTech. In the session 1, we will have 2 presentations, and after that, we will have a Q&A session. So the first presentation is under the topic of research and empirical case for digital factory transformation based on food tech in the food industry. And this presentation is prepared by Mr. Hyun, a research head of the Korea Food Research Institute. He's here at the site, ladies and gentlemen. Please welcome him with a big round of applause.
네, 안녕하세요. 반갑습니다.
Hello everyone.
우리 컨퍼런스 국제 컨퍼런스 개최를 축하드리면서
Congratulations on hosting the 13th FoodPOLIS International Conference, and today I will talk about developing a standardized model for food manufacturing process and industrialization of manufacturing robots. And from 5 years ago, using video and sensors, robot standardization has been processed. And due to the time constraint, I will keep myself brief. And FoodTech is being explored by many different government agencies, and Ministry of Agriculture and Food and Rural Affairs considers that FoodTech is a combination of food and technology, and Ministry of Food and Drug Safety is using cutting-edge technologies in the food industry, and Ministry of Trade, Industry and Energy is trying to digitize the value chain using this technology. And FoodTech utilizes robots, and especially intelligent robots. And in the food tech industry, I think in the logistics, packaging, and data-related industry, they will be used more. And alternative food and meal replacements have developed a lot, but like pre-processing and food manufacturing are being lagging behind other manufacturing industries. But this, in the food cluster, a lot of new sectors are being formed. And FoodPOLIS is actually leading these efforts. And there are 4 key issues. One is the reduction in the number of labor force. Second, old and outdated manufacturing facilities. And third, lack of quality, safety, and production management. And as you can see, there are no automated system or facilities. And that's why we believe the companies will need to get support with these new and cutting-edge facilities. And the biggest hurdle to applying the robot and automation system, people don't know how to extract, collect, interpret the data, and utilize the data on the field. And they also lack enough understanding on the automation. And using ESS, the government is focusing on HMR, and also the field is trying to use ERP, but there is not enough training being done to nurture talents. And these efforts should be involved in the development of the food tech industry. And after building the standardization process, we will need to industrialize the food manufacturing digital platform. And this future-oriented digital platform, please refer to the leaflet we provided. And then we have studied the markets, and there are different markets for HMR, home meal replacement, and export-oriented SMEs manufacturing model, and also traditional food manufacturing model, and franchise stores manufacturing model. And analysis should would be conducted based on each model. And kimchi, 50% is about cleaning and 30% is pickling and dehydration and packaging, and cabbage core and stuffing only takes up 13.6%. So we need to collect the data and analyze the data on the food manufacturing, and then we will need to form a structure out of unstructured data. To do so, we will need to interpret and study the unit process and create the standardized model for manufacturing robots, and we will need to customize and improve the robots, and then put robots on the site and field, and then we will need to improve the manufacturing environment and hire more staff and minimize the fatigue of workers. And the biggest issue of robots in the food industry is that how to integrate robots in with know-how and tradition of the existing companies. So for about 5 years, I have been creating the standardized model for food manufacturing industry and plants. So first is to supply ingredients and pre-processing, cooking and processing, and also analyzing the process applying manufacturing robots, and then standardizing the commercialized or actual robots. Only if this model is standardized, then although the owner changes, still there would be a continuum of work or consistency in work. And for the entire process, we have visited 140 companies across 5 years, and what was most important was SMEs created one process, made profit out of it, and then created other plans. So it was really difficult to standardize their process because SMEs were developing step by step, and it was really difficult to standardize SMEs model. So we talked with head of the factory and workers and listened to them and incorporated their feedback in our model development. So we selected the item, created a plan, standardized the process, and then created a manual. And then let's look at the data we collected. So a worker usually screens with their bare eyes, but it's difficult because there is a light and visual interference. And by using the video screening, we can increase efficiency, and this video can actually sort out any contamination or not qualified products, but also robots should not interfere with human workers. That's why the safety device and safety function is a must. And that's we realized that with machine learning using cutting-edge technology. And kimchi is the everyday, eaten in everyday meal in Korea. So let's look at kimchi production process. So here, there is a lot of manual work involved. But so we needed to determine when to introduce and adopt robots and what kind of data to enter. Then, by automating with putting robots in the process, we standardized the model, and then when we collected the data, we saw motion control and collected the data again. Then this data was used to production, R&D, and quality management to provide solutions. And so this model can be customized after being standardized. standardized.
안전한 식품 제종과
So this
전통을
helped
버리지 않는 그런 분야에서
manufacturing
K-푸드가 발전할
food
수 있도록
in a safe
앞으로
way.
진행할
So this is
예정입니다.
how the K-food,
여기서 이제
Korean
예를 들어
food
보면
can
저희가 이제 몇
further
개 기업에
develop
이렇게
in the
영상들
future.
처리해서 이
And
작업자들에 대한
this is a video
실질적으로
processing
촬영을 한 달
to
동안
help
모니터를 했습니다. 그래서
workers, and
컨트롤
we have
시스템과
monitored
공정별,
this video
보면
screening
로봇,
for
행정과
about a
모니터링을
month, and then
했고요. 거기를 통합 모니터링 제어를 했습니다.
here
이런 걸로
there
가지고
was an integrated
다양한 부분을
monitoring.
구축하고 통합해서 이런 부분들이 현재
We have
식품연구원의
built the
데이터 센터가
integrated
만들어져서
database,
운영을
and
같이 하고
currently in our
있습니다.
research
마찬가지로
institute there is the data center, and also companies in the national food cluster can also utilize digital twin and make a good use of the system we developed. And
개발 중에 하는 건데요. 배추
this is
실생입니다. 이게 지금
what we are
실제로
developing,
봄, 여름, 가을
removing
배추의
cabbage
원물이
core.
상당히 다릅니다.
So
밀도도 다르고 크기도 다르고
the
또한 그 안에
size
성질도
and
다르고
density and features of cabbages are all different, and also the size of the edge is all different. So by using video screening, we can understand the axis X and axis Y of cabbage and then remove cabbage core. But this technology has not been developed completely. Still, with a slight advancement, we were able to improve efficiency by 25%. By efficiency, I mean that there is less food waste and less time is spent. And here, many foreign laborers have been doing a lot of difficult and dangerous works, but those works were replaced with industrial robots. And the use of industrial robots is aimed at reducing the number of workers and increasing efficiency. And then here, if manual works are being done, it becomes really dangerous. And to prevent safety incidents, we have replaced these human workers with robots
몇 가지가 있는데 이 김치의
to set the direction, and then
원물에
there
대한
are
손상입니다.
several
원물에 대한 손상이면 숙성이라든가 기타 등등
issues
가루
with
같은 게
kimchi.
무너지거든요.
So
그래서 그런 부분이 때문에 굉장히 어려워서
when cabbage
여기서
core
뭐 200kg,
is
100kg를
removed and
이렇게
then the seasoning is done, we need to make sure that cabbage is still has a good quality. And here, this is about palletizing, and after palletizing, workers were stacking this kimchi, but now this work is replaced by palletizing robot. And so when to load and where to move are all simulated, and then we analyze the production rate, or operational rate, and then the amount of production. And then we were able to know when workers felt tired the most, and then the productivity went down the most. So this is the 3D modeling and simulation we did, and we were able to understand the work time of work and break time of workers, and what kind of activities and motions are most needed, and what's the allowable load, and food needs to be safer. So we wanted to secure food safety with this robot process. And then we visited 140 companies and developed 16 standardized processing model, and carried out 46 demonstrations. And let me share with you the key achievements. And of course, productivity has increased, but the key takeaway was that the defect rate was reduced significantly. And let me share with you the best practice. This company used 2 types of robots to improve productivity and reduce defect rate. And here you see this used to be done. This moving kimchi was used to be done by 6 or 7 workers before, but this work was replaced with robots now. And then
보급하기 굉장히 어렵습니다.
And it's really difficult to develop this kind of technology because some products need to be like flipped. But like the thing here is like if this packaging is contaminated with human hand, this becomes really tricky because this is food and it can lead to foodborne illness of customers. So now these robots are cleaner. So they use optical sensor to do packaging, and then this is the company who gets supply is Primo1, a big company in Korea, and supplier is an SME called Asetech, and there were 3 cases, and actually one robot covered 3 output lines. Before human workers did this work, especially using this vacuum pad, like the SKU is moved and then palletized, and this supplier made a lot of achievement, and then this one supplier is Gyeonggi Information Tech, and here this is a really dangerous task. If human workers do this, they need to pull these heavy SKUs up, but now this work is done by robots. So 6 to 7 workers used to do this work throughout the day, but now this is industrialized. The key here is all the downstream and upstream industries should use standardized model, and this company is the Korean traditional food company, and here like many human workers were really stressed out of this work. So we now see, you can see that this capping process is all automated, and robots put these things into the machine onto the rail, and the productivity increased significantly. So robots can be used for these works. Of course, it was really difficult to apply robots on the site, but still we made such an achievement. And then next, this is about cabbage. And camera controls the location, and then robots track this cabbage. And the core technology is, if more data is accumulated over time, then the depth of the cabbage core will be able to be found out, and then the fiber residue can be removed, which will enhance the quality of kimchi product. So this uses location identification technology, and then next this is using AM, and the multi-joint robot AGV is being used. And here you will see a consumer has ordered a product online, and then this robot stores the SKUs and products, and then these products are delivered to consumers. So the actual product selected by a consumer online is delivered to the customer's doorstep. And then this is really difficult work. So this was like 100% manual work, but we have changed this to half automated work and then 100% automated work. This was not easy at all. And here you can see that there are only 2 robots, and they are replacing 14 human workers, and this is the managerial robot. And in casing, you can see the line automatically opens, and then this APC and smart farm, which is most important in Jeollabuk-do, are being automated for selection, grading, and encasing and palletizing. So all of this process can be automated to address the issue of a lack of labor force. And then this is about bakery bakery products. So robot lifts up the plate, and then these bakery product is coated, and then the price is attached. So the entire process is 100% automated without human labor. And then this is vacuum pad, and this is disinfected automatically. And then this is an ice cream company called Seoju, located in Iksan. And there was a lot of there was high defect rate before, but now, like with automation, the defect rate has been reduced dramatically. So in the future, we will continue to develop these robots and models and provide them to sites. And safe production is key here. And these industrial robots actually protect the safety of human workers. And this will be a food tech technology in the future. Well, thank you for listening. Thank you.
Thank you very much, Mr. Kwon. Thank you for introducing us to robotic systems throughout the food manufacturing process. I believe that whether it's AI or robotic, these technologies are created by human hand. And it is our responsibility now to determine how and where to utilize them. Therefore, we need to gather our wisdom in order to understand them properly and use them in the right direction. Thank you once again for that first presentation. And the next speaker also shares the same concerns. We will now invite Director Navid from Cognex onto the stage. Today, she will be delivering her presentation on the topic of technology of machine vision and deep learning in the food industry. Ladies and gentlemen, let's welcome her with a big round of applause.
Well, good afternoon, everyone. This is Navid in charge of Korea packaging team as a team manager and Asia packaging team as a team leader. Well, I'm pleased to stand here to introduce the machine vision and deep learning technologies of Cognex in front of such honored guests. Well, this is the very first time for me to stand such a huge international conference, so if I make small mistakes, I would be much appreciated to understand with your generosity. Well, deep learning, smart factory, and AI, machine vision, these are not the new technologies or unfamiliar anymore. They are the essential parts in all industries. But still, some of you are wondering how these technologies are working or used well in our industries. So I'll explain today about the vision technologies and deep learning solution and how they are really worked well to develop the food industry with references. Well, I'm going to start by giving background and the basis of the market trend of the food industry. Well, COVID-19 is over, one of the tough times in our history. And it brought a lot of changes, and the changes are still in progress unexpectedly. Well, with COVID-19, interest for safety becomes one of the most important part ever than before. People want to ensure their safety and the quality of the product that they buy. And also these products are getting more diversified. And the depopulation is another important issue all around the world. And every year, the birth rate is decreasing and it causes labor shortages. Companies should pay more to maintain their production and to develop their working conditions as well. Also, carbon neutrality, one of the topics from last conference, is another important issue to keep the earth better. And for this, government encourages companies in various ways. With these movements in food industry, well, global research company Market predicts that food industry would be the attribute to a growth for demand of vision technology. And it also predicts that the Korea vision market will grow faster than ever before. And among all industries, food industry would be the fastest growing area. But still, 10% of a global population is working as a visual inspector. You are still depending on humans. Then why do we need machine vision? What is machine vision? Well, we need a machine vision to improve the productivity of the manufacturing lines. And we need machine vision to improve the quality of the product. And we also need a machine vision to improve traceability to managing the whole history of manufacturing. Well, machine vision sees the object or the situation with the optical parts consist of a lens and lightings like we do with our eyes. And it thinks about the situation and the object with the embedded software like we do with our brain. Well, we can do many things with vision technology. We can guide, we can inspect, we can gauge, and we can identify the object or situation. Machine vision can do many things, more than you think. Then if machine vision can do everything, why do we need deep learning? Well-skilled human inspector is great. They have a powerful brain and intuition with their experiences. But human has a limitation. They cannot work consistently, and they are easily affected to their emotional and physical conditions, and human causes a cost. That's why we moved to the machine vision. Machine vision can work 24 hours a day, 7 days a week, and a whole year. Machine vision is faster and more accurate and more reliable, but it also has a limitation based on the capacity of the connected host device, like a volumation. To cover a wider range of the complexity of applications, we move to a deep learning. Well, we need the flexibility of human and the reliability and consistency of the computer system at the same time in our manufacturing sites. Well, deep learning is a combination of a human performance and the computerized system. And Cognex has been leading global vision market over 40 years. And every year, we invest our revenue about 16% to R&D. Well, with a continuously investment and development, Cognex has 3 different types of vision technologies. They are rule-based vision, that is the traditional one, and the deep learning technology, one of the hottest topics these days, and the latest, the new types of deep learning technology called edge learning. Well, now that we have covered about the background and the market trends basis of the vision technology, let's move on to the next phase to take a look how these technologies are used in our industry with the references. Well, to improve the productivity of manufacturing line, we need a vision technology. Well, you can see from the video, human inspector cannot cover this severe situation. You need to pick the correct product with the exact position under high speed and the even irregular condition of the package. And this is why we need a vision technology to improve the productivity. And to improve quality of the product, we also need vision technology. Well, quality issue in food industry is increasing every year, and most are related to foreign materials and the OCR marking condition and the packaging status. Well, foreign material inspection is one of the challenging applications that is covered by vision technology in food industry. Well, we totally cannot predict what types of foreign materials will be appeared and where, and the rule-based vision neither do. So that is why we need a deep learning technology to solve this issue to improve their quality by training the various case of types. And deep learning technology can connect it with other vision solutions like X-ray system. Well, sometimes you need to detect the defects inside of the package, but the machine vision cannot see the defects inside. So you can use the X-ray system to see the object directly inside of the package. And you can use the 3D vision system to detect or check the whole condition of the product. You can check the height or volume or the condition and the correct types and consistency of the products or bundle with the 3D laser type by scanning the whole area. And to improve our traceability, you also need a vision technology in your field. Well, this is one of the best part to explain why we need deep learning for this. Where rule-based vision, traditional one, can read the OCR data, but it has a limitation and it needs the standard based on the some specific value. But by time goes and the industry is getting diversified, marking conditions cannot be the same always. So you need to read the OCR data exactly and correctly under various conditions. You can read the data on the surface that is high reflection, and sometimes you can read data on the wrapped or overlapped printing, and sometimes you can read the data printing right on the background without any guidance. And these all cases are the current status and current condition in the food industry that we are meeting now. And you can also the forming of the product by deep learning technology, by training of the various images as well. And you can also check or inspect the conditions of the package by the training for the various types of cases of the packaging with the deep learning technology as well. But recently, industry requested something new types of technology that is easier, faster, but based on deep learning technology. So Cognex has launched the very new type of deep learning technology that is called edge learning. There are 3 key features of edge learning. Well, you don't need hundreds or thousands of images for training, and it allows to shortening time for training as well. And also, no need for higher spec of PC or GPU, and no education is needed to use it as well. Well, as you can see, the bottom side of the page, only at least 11 to 12 images are used to train for the case. And when we did the on-site test, we completed whole test session within 12 minutes. This is one of the key features of the edge learning that is developed for easier usage and a faster result. And also to prevent mixing products in manufacturing lines, edge learning can classify the types of the products in manufacturing lines by training the whole images. And it is also hard to cover by the traditional rule-based. And edge learning can read well for the various types of the OCRs as well. It can read the OCR that is removed or damaged or on the reflective surface, maybe overlapping, and even Korean and other languages as well. And edge learning also can check the condition, like locations, alignment, and the wrapping and crack, conditions of the product by a training and the simple clicking to a setup. Well, of course, this is not the all for our reference, but like these, machine vision and deep learning can be used more than you think in our industry. Machine vision and deep learning can ensure the product safety, and it can improve the productivity, quality, and the traceability. And also, machine vision and deep learning can protect the brand reputation and the brand images as well. Well, still some of you are wondering, is it really work or work well? How is it used in the application? Well, you can just contact Cognex or contact me to see the feasibility. And I hope my presentation would give a chance to consider to adopt the new technologies in your manufacturing sites or your company to help to develop their conditions by giving the reliability of technologies and trust. Thank you for listening.
Thank you very much for that presentation. Great technologies and the wisdom to use them effectively are indeed crucial. Thank you for sharing Cognex machine vision system in order to improve productivity. So ladies and gentlemen, now we'd like to open up the floor for Q&A session. We'd like to welcome our two presenters once again up onto the stage. Due to limited time, we will have about 2 questions from the floor. If you have any questions, please let us know. Yes, sir. Can we pass the microphone?
네, 안녕하세요. 저희 한국식품산업클러스터진흥원
Hello,
식품벤처센터에
this
위치하고 있는
is
농업회사법인
a
주식회사
food
진료대입니다.
company
저희는 우리
in
농산물로
the
젤라또
National
아이스크림을 지금 수제로 만들고
FoodPOLIS
있고요.
cluster, and we are manufacturing the food by ourselves. And you mentioned that robots and other automated devices or processes should be utilized more to improve safety and productivity in outdated work environment of SMEs. And aside from economic aspects, what do you consider the most for automation of SMEs?
질문 감사합니다.
Thank you for your question.
제가 현장에 한 140군데를 다녔다 보니까
Well, I visited 140 companies, and as you mentioned, like many SMEs are reluctant to show their sites, and the key here is the communication with site staff and site personnel. So, if
대응이 안 돼요.
I don't know well about technology as much as site staff, then they are not willing to talk to me, so I need to know more about technology than them, and I need to provide solution to the issues they are suffering from. So to do so, the process should be improved and training should be provided to nurture staff. And the sites do not like change because they need to change the work route, and also workers are worried that they can no longer work in these sites if the site is automated. And second, there are many supportive projects and programs for SMEs, and there are projects and programs provided by central government and local governments. So it's like then the government can provide support up to 70 or 80%, then a lot of improvement can be made, and especially productivity and defect has been improved by 30 to 50%.
Answer, and of course, thank you for the question. I think we can have one more question from the floor. Yes, sir. I think you're the only one. So can we have your question? Yes.
안녕하세요. 저는 김제
Hello,
농산물발전고등학교
this is teacher 정윤진.
예소원 이사님께
I have a question to Ms. Ye.
우선 머신 비전을
So
활용한
you
식품
talked
위생
about how
제품의
machine
실제
vision can be
정보에
used to
대해서
detect foreign substances, and thank you very much for your presentation. So I have a question. There are a diverse range of foods, and there's a lot of process, and which is complicated. So I want to know where, is there any experience or process and sector where it was difficult to apply machine vision? Well, first of all, thank you very much for your time. And like you said, and like I said in my presentation, food industry is the area where it is most difficult to apply machine vision. As you know, because there are so many cases and types of products, and the environment is just so diverse. So there's no single solution to cover this diverse products. So we also test And we
거의
also
한
do
1년
POC
가까이
test in the
테스트를
field,
지속을 했던
and we continue the test for about a year for a company, food company. And I think this can answer your question. So operators of that company
솔루션에 대한 뭐 퀘스천이라던가
had some questions about the solution and whether this technology is really needed, and they were not reluctant to accept this technology. So their mindset. So it was very difficult to persuade them, and our client has some standards. So they use the standard to apply machine vision, and we run tests based on that standard. But when we introduce machine vision to the field, because it's a food industry, the client may find some new types of conditions or new types of environments that were not known to the client itself, and there are new rules. So there's been some kind of conflict between the old and new found
Thank you very much
rules.
for sharing your knowledge and insight. And due to limited time, we will conclude the Q&A session right here. Ladies and gentlemen, let's give another big round of applause to two presenters. Thank you.